since you guys are going to be scientists and engineers. Okay. So today in lab, you're going to look at the kinetics of the iodine clock reaction. For the iodine clock reaction, you mix a solution of IO3 minus, this is the iodate ion, with a solution of HSO3 minus ion. These two solutions are colorless solutions. So when you mix these two solutions together, it's colorless and colorless and colorless. Then all of a sudden the solution turns blue. I was actually at a conference about 10, 12 years ago. And a speaker at the conference actually used this iodine clock reaction. He gave like a 45-minute talk, and 15 minutes into his talk, he pointed at this very large graduated cylinder, then it all of a sudden turned blue. So everyone in the audience was very impressed. Then 10 minutes later, he pointed at another large graduated cylinder. That one turned blue. Everyone was even more impressed. And then 10 minutes later, he pointed at another one. It didn't turn blue. And he pointed at it again. Still didn't turn blue. Finally, after pointing at it 3 more times, it finally turned blue. So he was using the iodine clock reaction. So for 2 of the 3 reactions, he did the right calculation or the correct calculation to make the solution turn blue in that period of time. But for his last solution, he either didn't time his talk properly or he didn't use the correct concentration of either IO3 minus or HSO3 minus to make that solution turn blue when he wanted it to turn blue. Okay, so that's actually one application of this iodine clock reaction. So anyway, this iodine clock reaction consists of 3 reactions. So there are the 3 reactions on the chalkboard. The reaction which makes these solutions turn blue is this last one. So it turns out that iodine, I2, in the presence of starch, will make a blue solution. Okay? Turns out that these 3 reactions occur at different rates. So of these 3 reactions, which reaction do you think is the fast reaction? Reaction 1, reaction 2, or reaction 3? Okay, so to help you answer that question, know what's happening. In reaction 1, IO3 minus reacts with HSO3 minus. That produces I minus. In reaction 2, this I minus comes from where? Yeah, that comes from the product of reaction 1. So in reaction 2, the I minus, which comes from reaction 1, reacts with IO3 minus. And where does the IO3 minus come from? That comes from also reaction 1. Okay? So the I minus reacts with IO3 minus in the presence of H plus or acid, and that produces I2. Once I2 is produced, that's going to react with starch in the solution, and it's going to make that solution turn blue. Okay, so of these 3 reactions, which reaction do you think occurs the fastest? In other words, these reactions do not occur at the same rate. Okay, so maybe what we can do too is let's draw a picture. What's going on here? Okay, so here is our reaction container. Okay, so in this reaction container, initially we have IO3 minus present. I'll put a few of them in here. Because we know that for a reaction to occur, reactant molecules have to collide together with sufficient energy for bonds to break. And I'll put some HSO3 minus in here too. Now, when you do this reaction in the lab, there's also going to be some starch in this mixture. Okay, so I'll put some starch in here too. Okay. Now, let me put a few more HSO3. Okay, so in reaction 1, note that 1 IO3 minus reacts with 3 HSO3 minuses to form I minus. Okay, so when IO3 minus reacts with some HSO3 minus, I minus is going to be produced. So as the I minus is being produced, note that IO3 minus will still react with the HSO3 minus to produce more I minus. But the I minus is going to react with the IO3 minus to produce I2. Okay, so note that if we have these two reacting together, actually it's not, we need 3 of these, okay, for every one of these to produce an I minus. Okay, so in other words, we have these two substances reacting together to form I minus, but the I minus wants to react with IO3 minus, and that's going to produce I2. Once the I2 is produced, that's going to react with the starch and make the solution turn blue. So there's 3 reactions that are occurring. So which one do you think is occurring the fastest? So this is reaction 1. This is reaction 2. And then this is reaction 3.
The third one once it begins.
So Juan, you say reaction 3 is the fastest. Okay? So I'll answer your question in just a second. So who says who agrees with Juan, reaction 3 is the fastest? Okay? Who says reaction 2 is the fastest? Who says reaction 1 is the fastest? Okay, now I want to make it clear that when the IO3 minus reacts, okay, so you have an IO3 minus solution. We call this, in the lab, we're calling this solution A. And then this is going to be mixed with the HSO3 minus solution. We're calling this solution B. Both these solutions are colorless. So these two solutions are mixed together. Okay, so now you have the IO3 minus and the HSO3 minus solutions. Okay, so they're mixed together in the same container. This solution initially is colorless. Okay, so this is a colorless solution. Then after some time t, okay, so after some time, this solution will turn blue. Now, if reaction 3 is the fastest, that means that as soon as I2 is produced, it can react with the starch in solution, which will turn the solution blue. So if reaction 3 is the fastest, as soon as the IO3 and HSO3 minus solutions are mixed together, the solutions turn blue. But that doesn't happen. Okay, so that actually turns out the reaction 3 is not the fastest. We have 2 more choices left, reaction 1 and reaction 3.
What's reaction 1? 2.
So is it reaction 1 or reaction 2? So again, look at what's happening here. We have IO3 minus reacting with HSO3 minus to form the I minus. Note that the I minus in reaction 2 wants to react with the IO3 minus, but the IO3 minus also wants to react with the HSO3 minus. Okay, so as soon as the I minus is produced, there's a competition for the IO3 minus. Okay, so note that the HSO3 minus and I minus are competing to react with the IO3 minus. Boy, there's all these I's and O's and S's and minuses. It's hard to keep track of all. So another way of thinking of this, just say that this is the latest electronics device that you want. And this is you, or this is your friend, and you really want that device badly. You want that new iPhone or whatever. iPhone, iPad, latest game console. You gotta get it. So who's gonna get it fastest? Okay, so that's how we can look at these reaction rates. So which one, the one that reacts faster will get to the IO3 minus faster. So there's going to be reaction 1 or reaction 2. Yeah, well, yeah, it's true. It doesn't mean it's faster though. So here's what we can do. In one case, assume that this reaction occurs faster. And then see what happens with reaction 2, which produces iodide, and reaction 3, assume reaction 1 reacts faster than reaction 2. In reaction 1, iodide is produced, and then in reaction 2, iodine is produced, which then turns the solution blue. In the second case, assume that this reaction occurs faster than this one. And then see what's being produced and why this solution, or why this reaction takes some period of time before the solution turns blue.